I'm the kind of person that will try anything. From studying abroad to athletics to theater, at Hiram, I have those opportunities. I've learned to ask what if a lot more and look at problems in different lights, and to live in the moment. My goal as a student and in life is to have no regrets. Because of Hiram, I feel like I'm ready for the spotlight.
At Hiram, I'm challenged to really think for myself. I've learned that there could be 50 right answers, not just one. My professors have been tough, but also so inspiring. They've really helped me find my focus.
Life lessons are what I'm going to take with me from my diverse community of coaches, professors, and students. Hiram has expanded my viewpoints and my beliefs. To me, Hiram means family. You get a chance to know everyone personally. Transferring here is one of the best choices I have ever made.
I try to humanize technology. I train students through Hiram's Tech and Trek program so that they can use these resources to work smarter.
Every day, I see students working to solve complex, real-world challenges. I truly enjoy fostering those conversations.
All right, so I gotta head. I'll see you later.
Okay, see ya.
People make the difference here. I've built relationships with my professors and my peers, so for me, Hiram is a really helpful, supportive environment. I'm learning more than what's in a syllabus or a course description. I'm figuring out how to network and get involved. Howdy, Mary.
Helping people is my passion, so I'm studying science and healthcare, but I'm also learning a lot about who I am. By taking care of the people, the animals, and the environment here, I know I can make lives better. I came to Hiram for a degree, but I'm leaving with so much more. I am ready.
Prepared.
A work in progress.
I am passionate.
Bright.
Confident.
I am the new liberal arts. I am
I am.
I am Hiram.
Visit hiram.edu.
Welcome to Fireside Chats, 60 minutes of stimulating conversation with some of Northeast Ohio's most interesting entrepreneurs. Get the inside story from folks who have taken the leap and who are willing to share what they've learned, the good, the bad, and the inspiring. Fireside Chats, real entrepreneurs, real stories, real learning. Fireside Chats are brought to you by the Center for Integrated Entrepreneurship at Hiram College. Be sure to look for our Fireside Chat podcasts where you can listen on your own time and our dime. For more information, visit hiram.edu/entrepreneurship. Now, let's get chatting.
Everybody here in the classroom and to our guests who I hope are joining us via live streaming. So this is our last Fireside Chat of the semester, but it is a first that we're using technology to take what's happening here on Hiram's campus and take it out to folks that can't make it in to join us. So those of you who have joined in, if you do have any questions during the course of this chat, please feel free to email your questions to entrepreneurship@hiram.edu, and we'll try to get those questions in front of our speaker today. So first off, today happens to be, this whole week happens to be Global Entrepreneurship Week, so it's rather apropos that for Global Entrepreneurship Week, we're also launching our live video simulcasts of our chats. I also want to say congrats to all of our Idea Blitz participants last week. We had 45 students with 13 ideas present to our panel of 5 judges. And our top 3 winners were Peter Sullivan and Megan McCoy with SafeCon, Katrina Leachman, Lisa Nazelli, and Emma Vaccaro with Style Savvy, and Winston Breeden, Jonathan Edwards, and Steve Krasinski with Waltrack. And those 3 teams shared in $1,000 in prize money. So tonight's speaker is Ashley Toten, who's the engineering project manager with Youngstown Business Incubator. And we're really excited to have her here. Ashley has a bachelor's in engineering and a master's of science in engineering and systems from Youngstown State University. She first got involved with additive manufacturing as a workforce and educational outreach intern students at America Makes, the National Additive Manufacturing Innovation Institute located in Youngstown, Ohio. So you can see where internships can lead you. So she's here tonight to talk about manufacturing in the 21st century and how advances in 3D printing technology is a real game changer, creating all kinds of opportunities in this expanding field. So welcome, Ashley, and
Thank you.
Look forward to hearing what you have to tell us.
Thank you very much. Thank you for having me. So welcome. Thanks for joining me. It's so dark out already. I'm so over it already. So today I'm going to talk to you about manufacturing in the 21st century. We'll jump right in. We're going to talk about what is additive manufacturing, 7 processes of additive manufacturing, materials, applications, and challenges. So to put this in perspective, manufacturing has existed for thousands of years. So over the past thousands of years, specific manufacturing processes have been developed. We've developed material removal, so subtractive manufacturing, where you take a block and you remove material and you get your part. Casting, you pour liquid metal into a mold and you get a part. Forming, molding, joining. So over thousands of years, we have about 5 or 7 manufacturing processes. And over those years, we've had some industrial revolutions that have went through. So you had your first industrial revolution when the steam engine was made. This was the mechanical revolution. Then you had a second industrial revolution where electricity was invented and also mass production. So the assembly line was created. We had a third industrial revolution where your digital age, computers, internet. And now there's talks of this 4th industrial revolution, which could involve cyber physical systems, artificial intelligence, IoT, blockchain, and this additive manufacturing. So when and where did additive manufacturing begin? It actually began about 30 years ago, 1984, by a guy named Chuck Hall. He invented additive manufacturing with the first type, which was called stereolithography. And he also invented the STL file that we use today. So now, since 1984, there have been 7 different processes of additive manufacturing invented, and they're listed above. So to put that in perspective, thousands of years we had manufacturing, traditional manufacturing, thousands. And we perfected it, and we've been using them for thousands of years. In the last 30 years, we had an additional 7 processes identified. 30 years. So what does the next 30 years look like? Just wanted to start off with that. So let's jump right into additive manufacturing. There's 3 basic steps, and anyone can do it. You have your design, your slice, and your print. Design, CAD software. Has anyone ever used CAD software before? Awesome, cool. What softwares have you used?
Just CAD.
CAD?
AutoCAD.
AutoCAD? Okay, cool, yeah. So computer-aided design software, there's hundreds of these. A lot of them are free. You can go online, download them, start using them today. Fusion 360, all students have access to this great CAD software. It's almost like SolidWorks, if anyone's ever heard of that. So it's very complex. So Fusion 360, people who are using it in industry, you can be using it today. You download it right online and students have access for free. Then there's ones like SolidWorks, Inventor, OpenSCAD, Rhino, CATIA, and the list goes on and on. So this is where you take something you draw and you turn it into a 3D model. So that's computer-aided design software. Another way to get a design is through 3D scanning. So you can either draw up your design in CAD software or scan something So there's 3 types of scanning. We have laser scanning, structured light, and photogrammetric scanning. So what this does, for example, the 2 that are shown, the first one's laser and the second one's white light. It just collects all these point cloud data and turns that into a model. The third one, photogrammetric, how that works is that you can download these on your iPhones, on any app. There's scanners out there now, and all this one does is it just takes hundreds of pictures. So say I wanted to scan this elephant. I would just get the scanner out, go all the way around him, and then it's going to take that model and turn it into something that I can 3D print or alter it and 3D print it out. So that's the second way you can get a design, is through 3D scanning. Once you have your design file, you have to save that as an STL file. And this is called standard tessellation or triangulation language. So what it's doing to your file is it takes whatever part you made, for example, on the right, that was a solid part, and then it puts all these little triangles all over your part. And the more triangles you put, the better quality your part's going to be. For example, the sphere that's on the bottom of the screen. If you only put 4 triangles on, it doesn't really look like a sphere, does it? But the more triangles you add, the more defined the shape becomes. So that's how you deal with resolution of your part and higher quality. So that's how you get your STL file. Once you have your STL file, then we can go into slicing it. So every 3D printer, you need to slice your part. 3D printing is adding it up layer by layer by layer. So slicing software, you put it in there and you can do all kinds of cool things with it. This is where you can play with infill pattern, layer height, speed, rafts, support structures, which are really important. I'll pass around this part. This part was stopped halfway to show you the infill pattern. You'll see a honeycomb structure inside. And your infill, you can adjust however you want. You can make your part completely hollow inside, all the way 10%, 30%, 50%, all the way to a completely solid part. So you have the ability to make that density of your part. I'll pass this around. Another thing you can do is add support structures. Anytime you have an overhang on your part, you're going to need a support structure holding that up, just like scaffolding on a building. What's really cool now with 3D printing is, for example, this part down here. Some printers have 2 extruder heads. You can print one in plastic and one with your model material, one with your support material. So your part material is black, your white material is support. So after this part comes off the printer, you plop it into water and your support dissolves away. So they're dissolvable supports, which allows you to create very complex shapes that you couldn't create traditionally. So I'll send around this part and it shows you the complexity of a part you can make. And I'll also send around a part that shows you support structure. This is a little penguin guy. You'll see support under his nose, under his hat. And then again, if he's dissolvable supports, you just plop them in water, they'll all dissolve away. Or if they're just your regular supports, you'd have to pick them all off. So you can see the before and after of this penguin guy. So how many, I'm going to stop here, how many of you are familiar with additive manufacturing or know what additive manufacturing is before this seminar? Raise your hand. What about 3D printing? Raise your hand. Okay. So I wanted to stop there and just show you. So 3D printing, I got more hands for 3D printing. 3D printing and additive manufacturing are the same thing. One's a more technical term, one's a fun term. So now you guys, everyone who rose their hand for 3D printing, you also know what additive manufacturing is. There's just 2 different words, but they mean the same thing. And then your third step is print. So you design, slice it, and you can go right into printing if you have a printer. So now we're going to get really technical real fast, but I want you guys to understand the possibilities in additive manufacturing. So most of the parts I just sent around are your traditional parts made off a desktop printer. That's printers you've probably seen, right? The little ones that have the reel of plastic goes into the extruder head, it heats it up, melts it down layer by layer. That's one type of 3D printing. There's types of 3D printing. So I kind of want to go over those with you quickly to show you what's going on in the world of 3D printing. So this is the first type of 3D printing. What it does is you have a liquid material. So it's a liquid plastic. It's called a photopolymer. So the girls in the room, gel nail polish now, you put it on as a liquid, it goes under UV light and it hardens. That's the same process that we're doing, but it just does it layer by layer by layer. So it's a photopolymer, it's a liquid plastic. A UV light hits that plastic and solidifies it, and it continues layer by layer by layer. This process is called vat photopolymerization. It includes a vat of liquid and it's photopolymer. It's also called stereolithography. I talked about that earlier. This was the first type of 3D printing invented in 1984. And now they've kind of upgraded this technology, whereas this part kind of looks like it's growing out of the liquid, which is really neat. And I forgot to, are we connected to the internet?
Oh, yeah, we'll have to get off the thing.
So I have quite a few videos to show, fun videos.
Are they embedded in here?
No, they're in it. They're just links.
Is that where you want to go?
Yeah. But this process, I'll keep talking, can create a very smooth part. So a lot of the parts I pass around, you could see all the layers, you could feel all the layers. I'll pass some parts around made by this process, and they're very smooth, have a very fine surface finish on them. And with this type of process, we can also use a material that has kind of a flexible property to it, so it acts as a rubber. And they're also partnered with Adidas, so they're 3D printing the soles of shoes for Adidas.
Oh, we had them here as speakers earlier
Did
this
you?
semester.
Oh, that's awesome. Yeah, and so that company is called Carbon 3D.
We had Chip Gear and Mike Warner from Technology Hub.
Those guys are great.
Well, unfortunately, it looks like it's not going to let me get on. I told you technology wasn't going to be my friend.
I can always connect to my laptop if you want me to.
It's not really doing it.
Can we connect my laptop? I don't know if I have this.
Yeah, it's on the Mac.
I don't have that.
Oh, was it the? Yeah, HDMI. For some reason, it's the cable's not connected. It's technology for you. to get on it, I guess.
Or I can just use my phone.
Okay.
It's fine. Or I can do this.
It'll just put
I
it
will
on.
just do it.
Might have to go in,
So I can just put my entire presentation up here too. We can connect to the.
You're on the HDMI.
Oh, here.
Is it going up? There you go.
I can just put my presentation up here too.
Okay.
So you've probably seen this video then if you came for the carbon.
Is it some?
Not to this.
Okay. So here we go.
I don't know if there is, but. So as you see, the part just, it looks like it's growing out of the liquid. So what's happening is beneath it, there's UV light hitting that liquid, hitting the build platform, and it's growing layer by layer by layer. So it's really neat. And you can create very complex shapes and geometries from this process.
Is that sped up?
It is, yes. 7 times the speed. So don't be fooled. It's not that fast, but it is really neat. Okay. Second type of 3D printing is, uses a laser or energy source, and then your material comes through as a powder, and the powder and the laser come together like in the picture, and it solidifies, and it does that layer by layer by layer. If any of you have seen welding done before or heard of it, that's kind of what this is, but it's very glorified and can do a lot of cool other things. This is the only type of 3D printing, and so it's called directed energy. Oh, I'm not connected to that anymore. Silly. Okay, it's called directed energy deposition, and this is the only type of 3D printing process. So normally, you know, you're 3D printing in one direction. It's going like this, layer by layer by layer by layer. This type of 3D printing is on a 5-axis head, just like a CNC machine. So it can deposit over here, deposit over here. It has 5 axes to deposit. So this type of process is used a lot for repair features, and I'll show some of that later. Third type of 3D printing process, which you guys are most familiar with, is material extrusion. So this process, you have your plastic reel, or it could be a pellet form, and it goes into the extruder head, it heats it up, and deposits it layer by layer by layer, like a hot glue gun. There's a lot of cool things happening with this. So we're familiar with the desktop printers, but there's big area additive manufacturing, or for short, BAM, where it's 20 by 7 by 6 feet long, and they're actually 3D printing bodies of cars in these printers, which is really neat. Fourth type is called binder jetting. This process uses a powdered material. So any type of material can grind up into a powder we can use. So metals, plastics, ceramics, sand, this is what we're using. So how this process works is it rolls out a layer of your material, and then an inkjet head comes over and squirts out a glue-like substance. So just like an inkjet head on your 2D printer that prints with ink on paper, it's the same type of inkjet head, but instead of ink, it has a glue in it, and it comes out, squirts it out, and does that layer by layer by layer. A huge industry that's utilizing this is the sand casting industry, which if any of you are familiar with, what it is it's you make a mold out of sand and then you pour liquid metal into it and you get your parts. So the automotive industry uses this a lot. Ford, for example, has been utilizing 3D printing for probably 20 years. Fifth type is called powder bed fusion, and I'll send some parts around that were produced by this. Again, it's a powdered material, but instead of a glue like binder jetting, it's using a laser. So it rolls out a layer of your material and a laser hits that powder and sinters it or makes it a solid, and then that happens layer by layer by layer, building your part up. I have a metal part here I'll pass around. It's a showpiece to show you what the capabilities are of 3D printing. So you have lattice structures, support structures, internal cavities that really show the abilities of 3D printing. And then so that's metal. I'll pass around the plastic one. What's really cool about this technology is all the loose powder that's not becoming a solid is acting as your support. So you do not have to add any support structures for this type of technology. Any loose powder acts as your support. So anything that moves or has a space in between acts as loose powder, so then you can create things that are movable without no assembly. So I'll pass these items around to show you that. And then this ball bearing. Traditionally, a ball bearing's made, you have your outer case, your inner case, and they have to assemble every single ball inside. So this is an assembly. There's about 16 pieces that go into one part, and it's assembled together. With 3D printing, this part comes out of the printer just like this, no assembly required, and it's able to move.
I just should have buy one. Like I really like the elephant.
If you would like one, I have my card up here and I can make you one. Okay. Let's see.
For thousands of years, manufacturing has been guided by the same principle. We'll take a block of material, we'll machine or we'll carve or we'll chisel, we'll remove excess material from it until we get to the final shape. It's not much different from a hunter way back in time takes a larger rock and breaks it into pieces trying to make an arrowhead. Even though we're using high-tech machining methods, the underlying principle is basically the same. But there's been a revolution in manufacturing. Today, we can start with nothing and build an object from the bottom up only using the material that we need. 3D printing is so revolutionary because of the efficiency of the process. We start with a flat bed of metal powder. Powder is our ink. The laser melts a thin layer of the metal. The bed drops a fraction of an inch. We put fresh powder over the top, and then we melt another layer until you have thousands upon thousands of layers to make an actual component. This gives us unlimited design flexibility. If you look at the vent tube that we made for NASA's Orion space capsule, originally they took multiple pieces and then assembled them together to make this one part. Each one of those fastening points creates a weak point in the structure. The beauty of 3D printing is we're able to print it all in one piece. For example, we actually print the screen integrally into the part as we build it, making a much stronger, much more efficient structure than you could before. One of the issues with traditional manufacturing is I can't physically remove the material that I want to remove because the machinery isn't capable of doing it. We can take that traditionally manufactured part, feed that into a computer program that looks at the loads and the environment that that part operates and reveal the true structure so that you only print material where you need it. And what often happens in these optimized designs is that they're very curved and organic looking, like they were grown from roots of a tree. I mean, there's a reason a tree looks like it does. It's because it's an efficient structure. Nature is the ultimate designer. Now I have a lighter weight part which goes on an airplane, which means it burns less fuel, which ultimately means a greener Earth going forward.
Sixth type of additive manufacturing process is called material jetting. So this takes an inkjet head again. Instead of a glue like binder jetting was, it actually has your material. So it's your liquid material, whether it's plastic or a photopolymer, and it squirts out that ink or your material layer by layer by layer and builds up your part. So I have a couple pieces that were made by that. What this process allows is you can print with multiple strengths of material or multiple materials all at once. So you'll see some of these pieces that, for example, this one that you'll see passed around that has a hard outer surface, and then inside is very flexible, and this was all printed at once. Then you'll see this little globe here. It looks like a GE tires inside, and it looks like someone placed it inside, but no. This was all made layer by layer by layer, and this process also allows you to use multiple colors at once. So I'll pass all of those pieces around. There's a lot of them. And then there's a little gear too that I'm passing around, and again, it wasn't assembled, it comes out of the printer just like that.
I came across Derby a little over 3 months ago now, I think. I had adopted a dog through this rescue group called Peace and Paws. He was born with deformed front legs. And I kept looking at his photo and hearing his story, and I cried literally every time. Finally, I messaged her and I was like, okay, I'll do it, foster, I'll take care of him. I had to try, and I had to try and help this dog. We decided to get him a cart, which worked quite well, but they limit his mobility in terms of being able to play with other dogs, and it's not really the full motion of running.
For develop this project, we're using a variety of 3D technologies, and that allows us to get in there and really modify the organic digital models quickly and easily, and start to do the sort of designs that Derek wants us to do.
3D modeling.
The great thing about using 3D technology in Derby's case is having these images on file on a computer and being able to print them is a lot quicker than having to hand sculpt every single mold and rebuild these braces 5-10 times.
With prosthetics in general, a lot of the designs are going to this running man sort of look. And I was concerned with doing a running man
That's the 3D printer, that's a material jetting printer.
And so that's really where
squirting out that material layer by layer by layer.
Hey Dirk, you got your new legs.
We started them off very low, and so that it wouldn't be too drastic, we have a line called the Project 5500, which enables us to run dual materials. That has really been key with designing his prosthetics.
I got it. I don't become impressed very quickly, but when I saw him sprinting like that, it was amazing. It just, I couldn't believe it.
The first time he was put on them and he took off running, he was just so happy. I was absolutely amazed at how well he did.
He runs with Sherry and myself every day, at least 2 to 3 miles. He runs faster than both of us. He never really tires out. He's just so happy to do that.
This is what 3D printing is all about. To be able to help anybody, dog, person, whoever, to have a better life is just, there's no better thing to be involved in.
So those prosthetics were made with material jetting, and it's just a great, one of my favorite videos to show the possibilities of what 3D printing can do. So they first started them off with that cart, you know, and that's what normally we would have access to, and he didn't have much mobility. And then with 3D printing and 3D scanning, they're able to scan his legs and make a prosthetic that fits him perfectly, and then you saw him running at the end. It's just incredible, so it's really awesome. And the last type of 3D printing, so we covered 6, it's the last one. This is called sheet lamination, and this process works. It takes sheets of material. In this case, we're limited to paper or metal. So it'll take the piece of, literally your printer paper, that's what it uses, that's what the printers use. It takes a piece of your printer paper, it glues it to the next piece of printer paper, and then a knife or a laser comes out and cuts that layer. And then it continues, layer by layer by layer. And once you're done, you take your whole, looks like a cake of white paper out, like that skull, and you break away it and you find your actual part. And you're able with this to use ink as well, so you get all this cool colors and designs. I have one piece that was made with the paper sheet lamination that I'll pass around to you. And then for metal, how that works is with ultrasonic welding. So you get a piece of sheet metal and you ultrasonic weld it to the next piece of metal, and that continues layer by layer by layer. So we covered the 7 different types of 3D printing processes. Now I want to go over what materials we can use for additive manufacturing. So again, the most familiar and used is polymers, so your plastics, either in your filament form, your powder form, rubberized form, or liquid form. So however we can get our plastic, we can use it. Metals, if you can grind up your metal, you can use it in a 3D printer. So you have a whole list of your metals. Pretty much there's no restriction to what metal you can grind up and use. Ceramics, I have a ceramic piece here. So your zirconias, alumina, silicas. The part I'm going to pass around was made with a material jetting process. So it's a liquid ceramic slurry, and it gets jetted out, and then the UV light cures it, and that happens layer by layer by layer. This printer is at the Youngstown Business Incubator that I work. It is from Israel. It's called the XJet 1400. It is the only one in the United States, and it is the 3rd in the entire world. So if you ever want to come see it, we welcome everyone to see that and our other equipment down there. We can print with sand and wax as well. I have these 2 materials on the same slide because they're used for tooling aspects. So I mentioned sand casting before. Has anyone ever heard of sand casting or investment casting? There are 2 types of traditional manufacturing. Sand casting has been around for thousands of years. You take a mold, you fill it with sand, you pack it down, and then you pour it in with metal and you get your parts. With 3D printing, we can now 3D print the sand molds and cores and then pour in your metal traditionally. So we're just utilizing it for tooling aspects, and we're not 3D printing end usable parts. I'll give it another example for wax is the jewelry industry. So all your jewelry, rings, necklaces, any very delicate or intricate metal piece is made using investment casting. Investment casting, real quick, how it works is someone has to carve out a wax pattern, and that wax pattern is going to look like the piece of jewelry. So for example, the ring I'm wearing. So they would carve this out of wax. Then they would dip the wax pattern into a ceramic slurry. It would harden, they would burn out the wax, and then they would pour in the metal that would be your actual piece of jewelry. That's how you get jewelry. So traditionally, for hundreds of years, people would take wax and they would carve out your shapes, and that's how they would get them. Now with 3D printing, we can 3D print your wax out and then do it traditionally. So wax patterns and sand casting molds and cores are 2 ways we can use 3D printing for tooling aspects. So I'll pass this ring around to show you. This one's not made out of wax, it's made out of plastic, but we can also burn that out and utilize it for investment casting. A fun fact for anyone who's a Cleveland Cavaliers fan still, their championship rings, those were 3D printed wax patterns. So it's a fun fact. Concrete, so we can 3D print with concrete material. This is being used for houses, and I'll show this quick video. This house.
From busy bees to a busy robot. Yes, this robot is building a house.
I can get a new house in 24 hours. I'll take it.
Invented by Russia's Nikita Chenyentine, this is a 3D house printer.
This is incredible.
So how does this robot make quick work of building a house?
This machine is the future of home building because using 3D printing type technology, it's able to build a house in 24 hours.
This 3D printer is so fast because it pumps concrete at an incredible rate. 400 gallons or 1,500 liters worth every hour. That's one bathtub full of concrete every 3 minutes.
Concrete's perfect for this because you need something that you can squeeze out as a liquid and then very quickly turns into a solid. So as the 3D printer puts down layer after layer after layer of concrete, it builds up a continuous solid wall.
This 3D printer is designed in a way unlike any I've ever seen before. Its main body is in the center and it has a long arm that can travel in a full 360-degree arc and move in and out. It can print up to 1,420 square feet or 130 square meters. That's the size of a 3-bedroom house.
The only thing the robot can't do are things like structural beams, windows, doors, and the roof. These things are still added by good old-fashioned manual labour. We're all fairly experienced with dealing with paper jams, but a concrete jam, I mean, that's your afternoon goal.
So this is a newer material that's being explored. So for example, that house was made in less than 24 hours for around $10,000, which is pretty incredible. And people are like, oh, why would you do this? But additive manufacturing as a whole, there's a specific reason, specific purpose, specific process. So in this case, why we would want to 3D print houses is, for example, low income areas or natural disasters. So a hurricane comes through, destroys an entire village, we can go in there and put up houses very fast so people can start living in them while their real houses get constructed. That's just one example. For 3D printing with concrete. Wire embedding. So not only can we print with plastic, but now we can print with plastic and also embed wires while we're printing. So UTEP, University of Texas El Paso, has one of these systems. They produced it. It's called a multi-3D printer system. It has a 3D printer that prints in plastic, and then it'll pause, it'll embed wires, and then it'll continue printing plastic. So you can see some of the cool things they're doing with like CubeSats, so little satellites they send up into space. They can embed all the wires and stuff, send them out. They'll collect all the data and they'll come back. I don't have any of the wire embedded pieces with me today. And human tissue. So another really cool material that we can really start looking into is the human tissue. You have an example of skin up there. Some of the reasons we want to do this, burn victims. So if someone was really badly burned, we can go ahead, scan their arm, and deposit new material down onto their arm. And then I'll just have this video play, and it'll talk about the rest of the cool things that are going on.
I'm Dr. Benasser, and my lab makes ears. The invention that we've discovered is a way to print living cells in a material that can be used to reconstruct tissues in the body. My laboratory is interested in regenerating cartilage wherever it's found in the body. The process starts with a scan of an ear. We sit someone down in a chair, and we have a camera that spins around their head and takes a 3D image of their head. We then can very precisely map out the topology of the ear. The next kind of key step is developing the ink for this printer. This ink is actually a living ink. It contains living cells. It's alive when we put it into the printer. It's alive when it comes out of the printer. The real power of the printing technique is that it can be used to make geometries that you just can't make with any other technique. You can make parts with holes in them. We can layer and cover and put different cells next to each other to create really the complex organs that make up our bodies. And after 2 months in an incubator, the tissue fills in and looks white, just like real cartilage. The implants that we're making are not rubber or plastic. They are alive. They grow inside the body or out.
So let me ask a question, because we had somebody text in a question, and it has to do with the bioprinting. And the question was, how does the future look for bioprinting, and how long till it's adopted, becomes mainstream for the treatment of human ailments? Any idea?
Yeah, that's a great question. So to give an example, probably 2 years ago now, they 3D printed a kidney. And they had it in an incubator, and it survived for about 3 months. Now, 3 months, it's not that good, but this is the very beginning. And for example, 3D printing of organs, what the hopes are, so usually you get an organ donated from someone else. Well, for 3D printing, they're going to take your own cells, they're going to replicate them, and they're going to 3D print you out a new organ utilizing your cells. So that way you're not going to have any rejection like you would from an organ being donated. The whole area of 3D printing of organs is very new. A lot of research needs to be done. But again, when you look at what's been accomplished in the last 10 years in 3D printing, it's absolutely amazing. It's an exponential rate. So I believe we will get there. I don't know when, but the research is being done all the time. And as a whole in the medical field, I mean, we're utilizing it for bones, for hip implants already, for dental industry. So the medical industry is heavily using additive manufacturing already. But when you get in crossover to the actual tissue of it, there's still a lot of research that needs to be done.
So where's the hotbed for biomedical or bioprinting, like the tissue printing? It's I don't think it's happening here in Northeast Ohio.
We have a bioprinter at Youngstown State University.
Do you?
So yeah, they're a lot in the universities, a lot in the clinics.
So where was this gentleman at? Did it say where he was at? You know, is there a
yeah, he
certain,
said where he was. He says it right at the beginning.
is there a certain area of the country?
I'm
or
Dr. Van Osser, and my lab makes ears.
Maybe he doesn't.
Oh, Cornell. It's Cornell
The
University.
invention that we've discovered is a way to print living cells.
Biomedical engineering in Cornell University.
Wow.
So probably all the universities that have biomedical, I don't know if YSU has that, but a lot of research is being done on that. But yeah, YSU has a bioprinter, but it's just one of those smaller ones, and it's just for research purposes. But there's definitely a lot more universities and clinics that are heavily focused into that area. Any other questions on bioprinting?
No, we can keep going. We have some for the end, I think.
Okay. To quickly go over why we would want to use additive manufacturing. So it's really cool, everyone wants to use it, and everyone thinks, a lot of the population refers to 3D printing as that desktop printer where you make little trinkets and keychains and cool things. But as I just showed you, there's a whole other area, and people have been using it for 30 years now. So car parts, the automotive industry, Ford, GM, the aerospace industry, Boeing, Lockheed Martin, GE, they've all been utilizing additive manufacturing, and they're all utilizing it for low volume. So you're not going to mass produce with additive manufacturing, at least not right now. It's low volume, and it's high customization and high complexity. So you put all those together and you have a great area for additive manufacturing. Part consolidation. So I might have some examples later, but You take a part that used to be 30 pieces assembled together, now it's one piece. So you're saving on time, energy, no more assembly is required, reduction of material and weight and all that stuff. Reduction in lead time, reduction in tooling costs. There's a whole area of why you would want to use additive manufacturing. You just have to find that sweet spot and then get into it. Design optimization is a huge area for additive manufacturing, and this is where the hurdle is in 3D printing. So again, for thousands and thousands of years, we've been designing for traditional manufacturing. We've had these restrictions on designing. We've been told to design a certain way. Now with 3D printing, design is kind of free. I hate to say that word, but you have the ability to create anything. Anything you can design in a CAD software now, you can 3D print it out. And you can utilize this to reduce weight and to create complexity. For example, this is a GE engine bracket that's shown up here. Traditionally, it's a block of metal, and you shave away and you get your part. So you have wasted material that you scrap, and the part is 5 pounds. With 3D printing, it's now under 1 pound. It was an 84% reduction in weight. And this is a part that goes on an airplane. So when you talk about less weight, it's less fuel consumption, which saves costs. Applications for 3D printing, and I've been talking about them throughout, but prototypes and models. So this is why 3D printing was originally invented, was for prototyping. So you can quickly 3D print an item out, test it, see if it works. If it doesn't, you just go back, redesign your part, and 3D print it out. It's very quick turnaround time, and it allows for you to do different design iterations fast. And then models. For example, back to the medical industry, they're using models for surgical planning. So they can 3D print out the patient's heart or the patient's brain, see what's going on, do the operation, see how it's going to turn out, and then actually go forward with the surgery. Tooling applications, so I talked about this briefly about sand casting and investment casting. This is a huge area for additive manufacturing. It's the low-hanging fruit because we don't have to do qualification and certification because you're just printing the tooling and making the part the normal way you would. For example, Invisalign braces, are you guys familiar with Invisalign braces or heard of them? So they don't 3D print the plastic piece you put in your mouth, but they 3D print the mold, and then that mold they vacuum form plastic over, and that's how they get your braces. So I'll pass around some teeth mold things. And so Invisalign, they are producing these molds in quantities of millions. So they are mass producing using 3D printing with mass customization because every human body is different. So your mouth is going to be different from your mouth. So that's why 3D printing is perfect for these molds. The dental industry in general, the medical industry is perfect for additive manufacturing.
Ashley, plus for those Invisalign, right? So as your teeth move, then they have to make a new
correct
clear brace.
Yes.
So which means they have to scan again and make another thing.
Correct.
And
So
make
not
another
only
mold.
is they have the customization from human to human, but they have the customization of every, I don't know how Invisalign works, but you get a different retainer every month or 3 months, I don't know. So every single one of those is a different mold, which is being 3D printed. And I have a picture of the International Space Station at the bottom. So NASA's into additive manufacturing. They have 3D printers up there. To give an example, for tooling, again, if they needed a tool, they would tell us down here at Earth. It would take about 3 months for them to get the tool back in space. Now they have a 3D printer on the International Space Station, so if something breaks or they need a tool, they can just 3D print it out and get it when they need it. Repair, so I talked about repair briefly. This is with directed energy deposition, which is the metal process. So there's a study up here of a bearing housing, And if they get worn, the company just scraps it, no matter what. They just scrap it. But with 3D printing, with this directed energy deposition, which is the 5-axis printer, they can put that part into the printer and it's going to deposit new material back on to where it's worn, or if it's broke, they can deposit new material. So doing that is 50% savings of buying a new part. So that's an example of repair. And then, of course, end usable parts. So this is where additive manufacturing is going. Everyone wants to print end usable parts. So I have some examples of the medical industry, a jaw replacement, and also hip implants. Hip implants are a great example of additive manufacturing. So you'll see it up there, that's the ball. And not only can they 3D scan and get those scans to make the implant perfect for your body, but they're also adding the lattice structure to the hip implant, which enables the bone and tissue to grow inside the metal part and become part of your body. So it's really neat what the lattice structure can do. And a lattice structure is like that metal piece I passed around and all those. It's a very complex shape. So it allows for the tissue to grow into that. I talked about part consolidation before. These are two great case studies. GE is doing a lot with additive manufacturing. The first one is the GE LEAP engine fuel nozzle. This part used to be 18 pieces they assembled together. Now they print it as one part, and it's 25% lighter and 5 times stronger than the original part. And they thought, oh, that's not good enough, so then they went to the next part. This part is 300 pieces assembled together. Now it's one part. So, and then they have another example. I think it's like 890 pieces that they assembled together, and now it's like 13 pieces, which isn't, it's amazing because to assemble all that, the time, the money, it's a lot, but now it's just printed as one piece. And there's the example of the car I was talking about. So they're 3D printing cars as well, just the body of the car, and they have to put the wheels and the windshields on, but they're still doing it. Oh, I think this is a cool video. Have any of you seen this before?
Imagine that you can design and build the car of your dreams as easy as playing a video game. The Hackrock digital manufacturing platform, powered by Siemens NX, is connecting virtual reality with artificial intelligence and advanced manufacturing to make this dream a reality. To prove this out, we started by sketching La Bandita, the car that we wanted, but nobody made. Quickly moving from sketch to full-scale photoreal 3D model in virtual reality. Allowing us to perfect the design and aerodynamics digitally. Moving back into the physical world and connecting with the Internet of Things. We deployed sensors and scanners to capture 50 years of automotive knowledge. We harvested massive data sets and used them to teach the artificial intelligence generative design engine what a car experiences. With artificial intelligence and machine learning, we have the power of hundreds of engineers at our fingertips, allowing us to grow optimized engineering solutions for our design requirements. These designs are too complex and expensive for traditional manufacturing. They have to be 3D printed. The synergy between Siemens software and hardware is allowing us to lead the way in large-scale 3D printing.
challenge section. It's that node right there that's really going to make or break this chassis. What we're doing right here, this is the key. Right. If we can get that node, then we can get everything.
We're now ready to print a full-scale car in aluminum. La Bandita is not a concept car. It's a proof of concept of an entirely new way to design and manufacture. And if you can build a car this way, you can build anything.
So the company that is making the outside of the car is located in Youngstown, Ohio. So that movie, or the video you just saw, is in partnership with the Youngstown company. And Hackrod, the one guy, Mouse McCoy, he is a movie director, and that car for that video is going to be in a movie that will be coming out about autonomous vehicles. So keep your eyes out for that.
Cool. So I understand too that doesn't Youngstown Business Incubator have one of the largest 3D printers?
Yes, so that's what I was referring to. The company is called Center Street Technologies, and they have, so I've shown you the BAM printer. It's even bigger than that. So it's bigger than 20 foot by 7 foot by 6 foot. It's the biggest 3D printer. And not only is it plastic, but they use the pellet filament, and it's carbon reinforced. To show you the difference of carbon reinforced and normal plastic, I'm going to send these two pieces around. The white is your normal plastic, a nylon material. Don't be too rough, you can break it. Just feel the flexibility. And then this is carbon reinforced plastic, and you're going to be amazed. It's amazing to see the difference of how strong carbon reinforced plastic is, which is the black material. So with anything, there are challenges, and I've talked about them kind of throughout the whole process, or out the presentation, and I know I'm running short on time. But design, IP, protection of IP, because now 3D printing is a digital item. So if I have it, I can send it to you. So how do we protect all of those parts and rights and stuff like that? That's a huge area for 3D printing and the challenge of it. Business case, material standards, qualification, there are quite a few challenges, and that's why there's so much research going on in additive manufacturing.
Ashley, so we have a question that relates to challenges.
Okay.
So 3D printing gives the common man access to many wonderful, exciting things, but how will society control the ability for anyone to use it in a negative way, such as printing weapons?
Great question, and that's another thing that I see a lot. So again, the media kind of covers just your material extrusion process, and then they also cover the 3D printing of guns and weapons. But yet, we've had manufacturing for thousands of years, and if you can 3D print it, you can also produce it any other way. So anyone can produce a gun. They've had the ability to do it. So this is just another manufacturing process to produce that. In terms of protection and data rights, that's the big area right now. It's called the digital thread and how to control it for additive manufacturing. I'll give you an example for the Air Force. So I do a lot with the Air Force. Traditionally, industry partner would print a part and send it to the Air Force. They put it on a plane and they fly it. Well, now government, they want to 3D print those parts in-house. So how does that work? Does industry still get a profit? Who has what rights? How does that work? There's 7 different types of 3D printing processes, and along with those 7 different types, there's hundreds of different machines out there. So how do we standardize this metal machine from this metal machine? How do we get the same parameters, the same part from this machine to this machine? There's a lot of different ways to control it. But yeah, I saw a video on how you can make a gun from cardboard before. I mean, if someone wants to make a weapon, they're going to find a way to make it. 3D printing is just another type of manufacturing process. And manufacturing's been around for thousands of years. Going to end with a couple slides specifically about Northeast Ohio, what's going on, and then what's going on in YBI. I'll do it really briefly. Several years ago, we conducted a study to see if Northeast Ohio could be a cluster for additive manufacturing. Just like Silicon Valley is a cluster for software, just like Napa Valley is a cluster for wine, we wanted to see if this area could be a cluster. So a whole study was conducted. And through that study, we found all these different traits, that there's 2,700 plastic and metal manufacturers in Northeast Ohio. There's all these universities. There's a huge concentration of materials, so many assets. So through that study, we found that Northeast Ohio has the perfect opportunity to be the hub for additive manufacturing. So because of that study, we now have a Northeast Ohio additive manufacturing cluster where we hold networking events, working groups, workshops, where everyone comes. We're trying to connect the supply chain. So you have material producers, machine producers, industry partners. We want to get them all in the same room and start collaborating and working together for additive manufacturing. And then real quick, the Youngstown Business Incubator also has a commercialization program focused on commercializing additive manufacturing ideas and startups. And through the program, we also have student teams that students are assigned to these startups to help with the commercialization program. So if you have an idea related to advanced manufacturing or additive manufacturing or 3D printing, or if you just want to be a part of a student team, go ahead, find the application online. You can apply, grab my card, you can email me with whatever you're interested in. There's a lot of opportunities for that as well. And how many of you did see Jim talk? So you know all about the entrepreneur side of YBI. So we have a big entrepreneur section and then a big additive manufacturing section, and this one kind of connects both. So it's entrepreneurship and additive manufacturing, and this grant sponsors that. And then I'm just going to end with this. So additive manufacturing doesn't solve every problem. So the quote is, if the only tool you have is a hammer, you tend to see every problem as a nail. So 3D printing is, the hype is up here. Everyone's so excited about it. Everyone wants to 3D print everything. But don't use the printer to print everything. Use the printer as another tool to your toolbox. Once you find the specific process, the application, every single thing has a specific application for it in additive manufacturing. You just don't want to print everything. And then any questions?
So, come on, there's got to be questions.
When can I get my 3D printed concrete house?
Right, yeah. There's a company in California that's doing a lot with it, and they just 3D printed one in Texas as well. So you see it's all in the warmer areas right now. Definitely. So we'll see. But
we'll be here soon.
Yeah, absolutely.
So I have a bunch of questions here. So what types of, like you talked about the 7 different types of 3D printing. Are you doing all those at YBI?
So real quick, the ecosystem in Youngstown, we have the Youngstown Business Incubator, we have the Youngstown State University, and then we have America Makes. America Makes is that National Additive Manufacturing Innovation Institute. Are you guys familiar with America Makes at all? Let me give you a real quick rundown on it. It was developed 6 years ago under President Barack Obama's presidency. He initiated the first manufacturing institute, and it was selected to be in Youngstown, Ohio. So it was the first one in the entire United States. Now there's 16 of them all over the United States, and they deal with different types of evolving technologies like flexible electronics. But so the 3D printing hub is located literally right next to the Youngstown Business Incubator. They're actually on our campus. So between America Makes, the YBI, and YSU, we have this great 3D printing ecosystem to tie that all in. The university was the second university to have all 7 types of 3D printing processes. So if we don't have it, they definitely do. In our building, we do have powder bed fusion, binder jetting, material extrusion. But the university, which is literally a 2-minute walk, has all 7.
Okay. So you talked about, so clearly there's, from that study, there are a lot of companies in Northeast Ohio that are in additive manufacturing, or maybe in traditional manufacturing, moving and could move that way. So I think maybe for our students, you know, we're talking about the future here. They're thinking about their future when they graduate. So what are the opportunities for jobs? What types of skills? You know, does everyone have to be an engineer? I mean, what kind of skills are companies using this technology looking for?
Great question again. So I hear a lot of people refer to, you know, engineering related to additive manufacturing, like that's the connection. To give an example, again, going back to YSU, we have a 3D printing lab in our STEM college, so science, technology, engineering, mathematics. We have a 3D printing lab in our art department, and we have a 3D printing lab in our business school. So that just shows you the areas, really, no matter where you want to go, there is an area for additive manufacturing. So you saw concrete, so there's construction, automotive, medical, the list goes on and on. Locally in Ohio, it's all those traditional manufacturing facilities, and we had a huge grant that we visited, I think like 100 different manufacturing facilities in Ohio. We went into the facility and we looked for areas that they can utilize 3D printing for tooling. And we did a demonstration project for them, and the grant covered actually 50% of a project to get them introduced to 3D printing. Because you don't want them to invest in the equipment and the machines, because these big industrial machines can cost $500,000 to $1 million. So we don't want them to buy something and then they don't like it and then they hate 3D printing, which we see a lot happening. So we want people to slowly get introduced and see what it can do. Going back to skill sets and opportunities, so there's a broad range. So yeah, there's the engineering, programming, all that technical stuff, but operators of machines and technicians are really lacking right now. So trade schools, that's a huge area. We can't find enough of them. And then, I mean, it just depends on what you want to do. If you have a passion for 3D printing, there's definitely a path to go into 3D printing. And then everyone thinks, you know, 3D printing is going to take over everything. No, traditional manufacturing will always exist at mass production. They produce millions of pieces. Everything you see, and this is why I love manufacturing, everything you see, everything you touch has been in the manufacturing facility. Everything's manufactured. The chairs, the glasses, your clothing, the food we eat, everything goes through a manufacturing facility, and it's really interesting to see that. And I have another presentation where I show a clip of a video of all these different manufacturing processes. It's really neat to understand that everything is manufactured, and that will never go away. So we'll still have our traditional manufacturing. It's just going to be tied in with our additive manufacturing.
So we had another question from someone who asked, when will the cost of printers drop to where they could become a common household item?
Great question. So desktop printers, the little ones that print with plastic, those right now you can get for a couple $100. You can buy them at Home Depot, Staples, Michaels, all those types of stores. You can buy those right now and put them in your home. The big industrial size printers that I said are like $1 million. That's another big challenge to additive manufacturing, is that you have this huge piece of equipment. It's very expensive, and you need to utilize it and amortize it in order to make your money back. Those types of printers, again, that's more of your industrial equipment, so those will never get into your home, just like everything that manufactures our items aren't in our home yet. But your desktop printers, not only material extrusion, but they have the little Formlab printers that print with the photopolymers. They have the So material extrusion, which is the filament, they now have metal filament, and they have it in a desktop printer, so you can print a desktop printer with metal, which is really neat. So a lot of material extrusions in your home, back photopolymerizations in your home, and all the other ones, they're becoming smaller and can be in the home. And the main reason 3D printing became so popular in the last 10 years, even though it's been around for 30 years, is because of the desktop printer. So all these big machines have existed. We've been doing 3D printing for so long, but because someone invented that small little desktop printer, everyone was like, oh my gosh, 3D printing, you can make anything, when it's been around for a long time, but it became more user-friendly and everyone fell in love with it.
Okay, so I think 2 more questions. Which country is at the absolute forefront of 3D printing technology?
Ooh, that's a good question. And it changes every year. The Wohlers report just came out. I haven't been able to read it yet, so I actually don't know. But Israel's doing a lot. Germany's doing a lot. We're doing a lot. But there is graphs and analysis on all that. I haven't read the newest version. If that person wants to email me, I could definitely give those statistics, because those are all in the Wohlers report. This guy, Terry Wohlers, he conducts a study every year on the state of the union of additive manufacturing, and goes all over the world to collect that data. So I can get that, but I don't know.
Okay, and one last question, and I want to show this to the folks that are tuning in, because they didn't get to see up close all your samples you brought. So this is the elephant, so I'm hoping that it's picking up on the thing with the movable parts, and it was printed that way. How long did it take to print that?
So that's a powder bed fusion process. So you're not going to print it one piece at a time. You're going to fill up that whole build area. So it's a powder process, and that was my favorite printer to run, because I was actually an intern at America Makes, side story, but you fill up the entire build volume, and I would print 300 pieces at once. So I don't know what one would take. On a desktop printer, you can print that on a desktop printer as well. So for 3D printing, really quick, the higher your part is, the longer it's going to take, because it's printing in the Z direction. So the shorter it is, it's quicker. So that one's pretty dense and thick, so it would probably take, I would say like 7 hours, I don't know. Depends on the infill too. So you have all these data and parameters you can justify. So if you make that completely solid, it's going to take so much longer. If you make it a 10% infill, it's going to print way faster. So you have all these variations you can do. I didn't pass these around, and I don't know why, but these bracelets are called Kinematic Nervous System hinge bracelets. The app's online. Everyone can create their own custom bracelet, and you download it for free and can 3D print it out on a printer. What's really cool about this, why I like to show it, is it's all hinges. That's what this company does, and they're doing jewelry and clothing. So they're actually printing dresses and clothing and stuff like that. So when you think about a dress, it's this big. How are you going to 3D print that? So with their idea with this hinges, so they design everything with hinges, and then they compress it down into a little ball. They'll print the dress in a ball in that powder bed fusion process, and then they take it out, and then they can have their dress. So it's really neat. I forgot to pass these around. But this one was printed with powder bed fusion. This one's printed right on your desktop printer, and it's still no assembly required, all your hinges. So there's a couple things I didn't pass around if anyone wants to see him. This little robot guy, his head spins, his arms move, he has gears on his legs. Again, no assembly required. There's so many things. Yeah. So.
Any last questions from you guys? Well, I think we. Pardon?
Where can I learn more about 3D printing?
Reach out to me, and I can give you a whole lot of things. Like I said, there's so much you guys could be utilizing for free right now. There's a website called Thingiverse. Real quick.
Yep. I mean, we had to use that for our coding class.
Oh, did you use this? So if you didn't want to design something, you can just go to this website and see if they have your design. You type in what you're looking for, and it's all free. So you can download anything and print it out. That's where a lot of these things are from, this cat, this thing, the elephant. They're all on Thingiverse. Like, for example, I'll search for a fox, and you'll get all these foxes, and they're all free, and you download it, and if you have a printer, you can print them out. It's really cool. But yeah, there's so many free things, free softwares, free apps. Just start utilizing it. It's really awesome.
And you said the bracelet was one you can download for free. Where was that from?
Show you really fast. So it's called Kinematics Nervous System app. So they have a necklace, a bracelet, stuff like that. The one that you can download for free is the bracelet. And it's all custom. Again, 3D printing is all about customization. So you customize the length of the bracelet, whatever the size, and then you can customize the shape. So you can pull things, you can push things, you can stretch it however you want. You can add different densities, make it however you want, and then you just download it and print it out. And that's how I have them up here.
And that can be done on a regular
Yes,
filament printer?
Yep. This one was done on a desktop printer. I did a study in college in my undergrad where I would just set up a printer in our lobby area and have people come down, customize them, and print them out right for them.
Wow. Okay. Well, thank you very, very much. Let's give Ashley a big hand. And again, I want to thank the people who we had about 7 people who logged on and watched our chat through live streaming, so we welcome them. And so if anyone wants to chat with Ashley for a little bit,
yeah,
please feel free to do so.
Yeah.